Hi students, welcome back to Vijay Datta chemistry classes. This is Purnima ma'am. Today we are going to discuss Faraday's laws of electrolysis from electrochemistry, and here applications, everything we are going to discuss. Please watch the video till the end and please do subscribe to my channel. And to understand the topic, understand the Faraday's first law and second law both, please watch the video till the end. Okay, students, let us start electrochemistry in that Faraday's laws of electrolysis. Okay, see here. What is this Faraday's laws of electrolysis? Here, Faraday has presented this in the form of electrolysis in the year of 1834. Faraday has been proposed these laws. What are these? The relationship between the quantity of electric charge passed through an electrolyte. The quantity, how much amount of the electricity is passing through an electrolyte, and how much amount of the substance. Suppose see here, it is the electrolyte, electrode, that is electrolytic solution. So if you are attached this one to the battery, how much amount of the substance is deposited at the electrode, means how can we say how much amount of the substance deposited at the electrode will be presented by the Faraday's laws of electrolysis. So how the electrolysis is going on, how much amount of the substance will be deposited, and how much amount of the current it is taking. Based on these points, he proposed this Faraday's laws of electrolysis. Okay, here he proposed these electrolysis based on two laws. So let us start with the Faraday's first law. See here, now Faraday's first law. So, what is Faraday's first law here? So, this statement is very easy, and Faraday's first law is very easy. How to state this Faraday's first law statement? Here, when an electric current, when an electric current passed through, when an electric current passed through an electrolyte, passed through an electrolyte, passed through an electrolyte, the amount of substance, the amount of substance deposited is proportional to quantity of electric charge. This is called Faraday's first law. Quantity of electric charge, quantity of electric charge passed through the electrolyte. Here see, before going to this, what is electrolyte, what is the electrode, we should know, right? See here, it is a container. In this, one metal rod is dipped in a solution. Then it is a copper rod dipped in copper sulfate solution. This CuSO4 is said to be electrolyte, and this copper is said to be the electrode. Copper is said to be the electrode, and the solution which is dissociate into ions, that is said to be the electrolytic solution, and the electrode which gain the electrons or loss of the electrons takes place in a rod, that is said to be an electrode, like we can consider. See here, again electrolytes, different electrolytes are there, strong electrolytes, weak electrolytes, like here we have taken the strong electrolyte, that copper sulfate solution, CuSO4 solution we have taken as the electrolyte, and it is a copper electrode. Then we passed some electric current into the solution, into the electrolytic solution. So suppose you have passed 5 amperes of current, you have passed through the electrolytic solution, then how much amount of the substance deposited at this electrode is directly proportional to the amount of the current you passed through the electrolyte. You have passed 5 amperes of the current charge within 5 seconds or 10 seconds, like that will be directly proportional to the amount of the substance deposited at the electrode, like he is telling. So if you have sent the 10 amperes, 10 coulombs, then the amount of the substance will be the same. You are sending the less amount of the current, less amount of the substance will be deposited at the electrode. So the current and the amount of the substance deposited both will be the directly proportional to each other. Already we know the Daniel cell. Daniel cell is nothing but copper rod dipped in copper sulfate solution and zinc rod dipped in zinc sulfate solution, and we maintain here the salt bridge. And here how much amount of the copper rod, how much amount of the zinc rod is zinc sulfate solution we have taken, and we are passing some current. That current passed through that electrolytic solution will be directly proportional to the amount of the substance deposited at that respective electrode. You are taking the, otherwise you have taken individually copper, you have taken copper sulfate, or zinc you have taken in the zinc sulfate solution. So how much amount of the current you pass it through the zinc sulfate solution, that will be directly proportional to the amount of the substance deposited at that zinc electrode. Okay, so that one we have to write. So weight is, W is nothing but the amount of the substance deposited at the electrode is directly proportional to the Q is nothing but charge. Q is nothing but current in time, means I is the ampere current and T is the time in seconds ma. Okay, so we can represent the Faraday's first law like W is directly proportional to Q. Okay, see here, a coulomb of quantity of a charge in current of 1 ampere is passed for 1 second. Here you have taken 1 ampere current, and 1 second, in 1 second time you have sent 1 ampere current, then that is said to be 1 coulomb of charge. So you have sent 1 coulomb of the charge, that will be directly proportional to the weight of the substance. Okay, so the amount of charge in the coulombs we can write it as I into T. I you can take even the capital letters I into T. So W is directly proportional to I is the current and T is the time in seconds. I want to remove this proportionality constant and I'll write W equal to Z into I into T. Z is the electrochemical equivalent, where Z is a constant, it is known as electrochemical equivalent. Electrochemical equivalent. Okay, see this electrochemical equivalent and the characteristics of the substances deposited will be given in this. Z is the electrochemical equivalent. See, where 1 coulomb of the charge is produced. 1 coulomb of the charge is nothing but 1 ampere current is passed through 1 second, then W is equals to Z. When W equal to Z, when current is equals to 1 ampere and time equal to 1 second, then W is equals to Z. So the electrochemical equivalent means the Z we can define as, the definition for the electrochemical equivalent is mass of the substance, mass of the substance deposited deposited by 1 coulomb. 1 coulomb is nothing but 1 ampere in 1 second is called 1 coulomb. Mass of the substance deposited by 1 coulomb, 1 coulomb of charge, 1 coulomb of charge, or by 1 ampere current, or by 1 ampere of current passed for 1 second. So this Z we can define is that mass of the substance deposited by 1 coulomb of charge, that 1 coulomb is nothing but 1 ampere of current passed in 1 second. This one we can represent the electrochemical equivalent. Z is nothing but electrochemical equivalent definition. We can write like this. For example, see here, when a charge of 1 coulomb is passed through the silver nitrate solution, means AgNO3 is passed through 1 coulomb of the charge, means 1 ampere in 1 second. The amount of the silver deposited is the amount of the silver deposited is W is equals to Z into 1 coulomb. 1 coulomb of the charge is passed through that. So, how much silver is deposited is 0.001118 grams is deposited. This 0.001118 grams is nothing but the electrochemical equivalent of the silver. This Z is nothing but called electrochemical equivalent. See here, W equals to Z into Q we can write. Otherwise, W equal to Z into I into T also we can write. This Z electrochemical equivalent we can take as the E by F. E by F is nothing but equivalent weight by Faraday's. This Z we can write E by F into I into T. E is nothing but equivalent weights of the metal. F is nothing but Faraday. 1 Faraday equal to 96,500 coulombs. Right? 96,500 coulombs. You can get the doubt here. How did we get that 0.00118 grams? See here, AgNO3 they have given. They said 1 coulomb. AgNO3 is nothing but Ag plus NO3 minus, like it is dissociate. Then W is equals to Z into I into T. I into T value is equals to 1 coulomb. Okay, he given that. So Z I can write E by F into 1 coulomb. Right? CO 1 coulomb. So W equal to equivalent weight of silver is 108 by Faraday is 96,500 coulombs into 1 coulomb. Then if you calculate this, you will get 0.001118. You will get this charge, this weight. So this much amount of the weight. So weight is nothing but obviously we represent with grams. Anyway, here coulombs will get charge. Equivalent weight doesn't have any unit. So double is nothing but 0.0118 grams. That is nothing but electrochemical equivalent value also we have got. Like this we can do. So this is also one of the formula for the Faraday's first law. This is another formula that depends on what is the data given. By using the data we have to use that respective formula. Okay, this is about the Faraday's first law. Now come to the Faraday's second law. Faraday's second law. So in the Faraday's second law, the statement is, when the same quantity of charge is passed through same quantity of charge same quantity of charge passed through different electrolytes. There we have taken only CaSO4 electrolyte, or in Faraday's first law only ZnSO4, only single electrolyte we have taken. But here same amount of the current we are passing through different electrolytes, then masses of the different substances, deposited at the respective electrodes will be ratio of their equivalent weights. Yes, and all should be connected in the series connection. That is very important. So All should be in the series connection. So I'll take here one example, that here I have taken the three containers here. So in these two electrodes are there, each one having the two electrodes, each one connected to the battery in a series connection. That is nothing but, see here, this one is connected to the this one, right? And also it is the plus, and then it is the minus, and again it is the minus, this one connected to this plus, again this is the minus, this one connected to the plus, right? Here they are dipped into some electrolytic solution. Here some electrolytic solution is there. Here it is the H2SO4 solution. Here electrolyte is H2SO4. Here it is CuSO4, and here it is AgNO3 solution. All are connected series. Now in all three different electrolytes, it is H2SO4, it is CuSO4, it is AgNO3, three different electrolytes, the same amount of current is passed through these electrolytes. So the amount of the substance deposited at these electrodes is directly proportional to the equivalent weight of that metal. Equivalent weight of that metal. See here, copper sulfate. Same amount of the electricity is passed, which is connected in the series connection. So equivalent weight of copper is how much? That will be the ratio of the substance deposited, means weight is divided by its equivalent masses. That will be like this. So how can we write? So see here, this is the figure H2SO4, CuSO4, AgNO3. So here I want to elaborate the law, that is mass of hydrogen by mass of copper is equal to, if first, because I am talking about the first, because these two are connected in the series, right? So first I am talking about these two. How much amount of the hydrogen, mass of hydrogen by mass of copper is equals to equivalent weight of hydrogen by equivalent weight of copper. Equivalent weight of hydrogen by equivalent weight of copper. Suppose if you want to take the relation between the copper and the silver, then you can write like this: mass of copper by mass of silver, equivalent weight copper by equivalent weight of silver. This is also the formula we can find. Otherwise, even here, silver and the hydrogen both are also connected. So you can write, you want to take those relation, then you can take mass of silver by mass of hydrogen equals to equivalent weight of silver by equivalent weight of hydrogen. Okay, so this is formulas which are both with the compulsory condition, they should be connected in the series connection okay. So the masses and equivalent weights we can count, we can calculate, they'll give their equivalent weights and equivalent masses. Okay, so this is about the Faraday's first law and the Faraday's second law. See, for hydrogen, if you consider the hydrogen, it will be the 1 by its weight we have to consider to find its charge, how much amount of the charge is passed through that. See here, the masses are in the ratio of their equivalent masses. From these masses, the amount of electric charge required to deposit one equivalent of hydrogen or copper or silver can be calculated. See here, equivalent weight of hydrogen, mass of hydrogen by mass of copper, right? So for hydrogen, if you want to calculate, Equivalent weight of hydrogen is 1 by its respective value. We'll get the coulomb value. So okay, you can take the mass of hydrogen by mass of copper. Ignore that. Just you calculate the mass and equivalent weights. You can use these formulas for the calculation of the Faraday's second law. So simply you can write W1 by W2 equals to E1 by E2. It can be anything. W of copper by W of silver equals to equivalent weight of copper by equivalent weight of silver. Yes, you can consider even like this the formula. Whatever the formula we have taken, the formula you have to be taken like this. Okay. Okay, guys. So in the next class, we'll go to the Faraday's laws applications. Okay. Thank you. Keep watching my videos. Please encourage me also. And also, please, if you have any doubts, please write in the comments box. Just I'll took that topic and I'll take that. And my system has small problem, that's why I'm not frequently uploading the videos. Definitely from today onwards we'll go to the daily one video on one subtopic of the chapter. Okay, either physical chemistry, organic chemistry, or inorganic chemistry. Okay, students, thank you so much.